Hi everyone. In this video, I'm going to share with you an analogy that I use to think about quantum numbers and orbitals. We know that with the quantum numbers, n, l, m sub l, and m sub s, that there are specific rules that govern the values that they can have and the relationships between them. Looking at the quantum numbers in the context of an apartment complex is going to help us to see how that is all laid out, and to hopefully provide you with a way to remember the rules. So let's begin. We know that let's imagine this apartment complex. We have 6 different floors, and on the main floor we have a lot of space that's taken up by various amenities, and that the amount of space that's taken up by the amenities decreases as we go up. So by the time we get to the 4th floor, not much space is taken up, and we have a lot of room left over for bedrooms. And so when we do this, what we can see is that we can develop a schematic or a way of thinking about the quantum numbers. So we know that with the quantum numbers, that for an n equals 1, we only have a single subshell, and that's the s subshell. We have one s, and there's one orbital within that. So in this apartment complex, we have our designer who is on the 1st floor put in a single room, and this room, believe it or not, is a salmon color. Now, I know that it's not perfectly salmon, but it's close enough. And he's given a room number to this salmon colored room, and he's calling it room number 0, and that's because he's kind of a quirky designer. And he's thrown in 2 beds, an upper bed and a lower bed. On the 2nd floor, he makes another salmon colored room, and this one also has a room number of 0, and that's okay because it's on the 2nd floor. You can distinguish between the first room, the room on the 1st floor, and the room on the 2nd floor by designating the floor number that you're on. Since there's more room on the 2nd floor as well, he's also put in 3 purple rooms. These purple rooms are always identical, with the exception that he had to put room numbers on them, and he decided to put room numbers -1, 0, and 1. Okay? Hopefully you're starting to get an idea of how this is connecting to our quantum numbers. If not, I'll make it more explicit in a little bit. On the 3rd floor, he puts in another salmon colored room, labels it 0. He puts in more purple rooms, labels them -1, 0, and 1. And that should be a -1. And then he puts in these rooms here. And these ones, we're going to say that the color of these is dandelion. Okay, so we have salmon colored, purple colored, and dandelion colored rooms. And notice that the room numbers on these, they're ranging. But we can still specify which specific room we're talking about. If we say the floor that we're on, we could say 3rd floor, salmon colored room number 0, or 3rd floor, purple colored room number -1. And we've designated a very specific room. On the 4th floor, we also have the same thing, salmon, purple, and dandelion colored rooms. And then the last color is forest green. Okay? At this point, hopefully you see that these are corresponding to the shells. This is our L quantum numbers of S, P, D, and F. We've designated a specific room by giving it a room number, and so that is our magnetic quantum number. And then we've also talked about the spin, although not here. The spin, remember, we can have up or down, and so we have our upper or lower bunks representing the different spins. So on the 5th floor, you can get all of the same things. When n equals 5, your L value can be 0, 1, 2, 3, or even 4. This is a gray colored room. And while we haven't talked about it, there are also G orbitals and H orbitals and I orbitals, etc. And so those go sequentially according to the alphabet. And that process continues on and on and on. There's no real upper limit. So what we see is that the orbitals themselves are representations, or are represented by these rooms. Each room in the apartment complex can hold 2 people. Each orbital within an element can hold 2 electrons. The values that they have, the shapes that they have, are based upon the quantum numbers. And by combining them together, we can define certain things. We can define our subshell by looking at the floor, or the N and L values combined. That is what we call the subshell. That's 1s or 3p or 5f, etc. If we combine the N, the L, and the M sub L values, that's specifying a specific orbital. In the same way that if I say I'm on the 5th floor in the dandelion colored rooms, room number 2, I've specified a very specific room to be in. And so the orbitals are our rooms for electrons, whereas the subshell, you can think of it as the floor and the color combined, that grouping. Okay? And then if we combine all 4 quantum numbers together, that tells us the location of the electron, or in the case of the apartment complexes, the location of a person. Hopefully this analogy made quantum numbers seem a little bit more concrete to you and gives you a way to think about them outside of just numbers and letters on a page. Thanks for watching and have a good day.